Hi, my name is Arturs, and we also have Menelaus, Mark, Jack, and Max, and we're a multidisciplinary team of mechanical and mechatronics students, and we would like to tell you a bit about our project.
Every year in the UK, approximately 157,000 people have a stroke, and in Leeds that is about 1,100 people every year.
Many people who have a stroke are unable to use their arm, and they need therapy to help them recover their use. And this places huge demands on rehabilitation resources within the NHS. And sometimes the recovery may take place within a few days or a few weeks, and other people may never recover fully. They may still have significant problems years later. The current therapy provision is based around rehabilitation staff, and therefore that's very staff intensive. Often if people cannot move their own arms, we have to help them move their own arms and practice during a therapy session certain movements, certain activities. The advantage of any kind of robotic device is that if it can offer support and assistance to the patient, instead of having to work directly with a therapist, then the patient can get more practice in without having to have a therapist actually with them for every session.
We've been working on rehabilitation devices for a few years, and it came time to develop a humanoid robotic arm that we could use for testing and hence moving towards commercial devices.
Patients who suffer from upper limb impairment often turn to robotic rehabilitation solutions such as this one.
The MyPalm robot is just one of many devices that is being developed. It is a simple rehabilitation robot for use in home. While there's a wide variation in the design and the complexity of devices across the world, the solutions all have one thing in common: they are all designed to interact with a human patient.
Now these solutions are very novel and they need rigorous testing and evaluation. Best way to do that is through other robots such as this one, which is basically a humanoid arm that mimics a human patient and helps to do durability testing over long periods of time. So we turned to the community for a design that we could use. We found InMove, which is an open source mechanical design for robotic humanoids. We only took the arm, but we used National Instruments MyRio to power it. In a matter of weeks, we were able to validate our mathematical models and we were able to build a solid foundation of knowledge for our future developments. Well, we found that this design is great for being deployed to physiotherapy departments and being used for acquiring of large amounts of data securely from patients to therapists.
The 3D printed design is great for remote physiotherapy because it replicates a human arm. However, testing with a motion capture system revealed it wasn't accurate or repeatable enough to be used over long periods of time. So we started working on a second design.
The second design is externally actuated. It uses 3 actuators to move each arm joint, a bit like a puppet. This design is more mechanically complicated than conventional humanoid arms, but is able to provide higher forces, improved accuracy, and repeatability. We also designed a custom robotic hand to integrate with the rehabilitation device. The benefit of using this approach is that the arm is back drivable. That means that the arm can be moved by a doctor or by the rehabilitation device to certain positions and used in remote rehabilitation applications.
The aim of the project was to design a human robotic hand which grasps the handle as a human stroke patient would and provide the same grip strength. So a mathematical model was developed of the human hand with the use of optical tracking and the average bone size of each finger. This was manufactured with the use of 3D printing, which allowed for rapid prototyping.
LabVIEW allowed us to develop complex and advanced user interface, allowing us to see live feedback from the system as a trajectory and also the 3D human arm model. Additionally, it allows us to tune and control every single parameter of the hardware. In this design, we've used industrial version of the National Instruments MyRio, which is known as Compact Rio or simply C-Rio. It allowed us to control 6 motors simultaneously and also acquire the positional data from various sensors such as encoders and potentiometers to perform complex kinematics calculations in order to perform nice and smooth movement.
To sum up, we have successfully completed the project by delivering 2 fully functional robotic testing solutions for rehabilitation robotics.
Thank you for watching.